It's October 20th, 2025, 5:59 a.m., and it's day one. Let's go. Since I'm building everything from scratch, I started with the basics, setting the video mode and drawing a pixel, which wasn't that hard. It was actually harder to get used to Pascal's syntax. Duh. Duh. But finally, a pixel. A single pixel isn't that useful, so I wrote a procedure to draw an 8x8 tile. I figured the logical next step would be to fill the whole screen with it. Damn, that's slow. Even though I could imagine what it would look like, I added a second tile and a loop to continually redraw the screen using a different tile. And it was pretty much what I expected. No big surprise that drawing that many pixels individually is slow, so I searched the manual for something like memcopy to speed it up by copying whole rows. It took me forever to find it. Move. Why is it called move? Jesus. It was definitely worth it. It's way faster than before, as you can see in the side-by-side comparison, but there's still room for improvement. But I decided to move on. My goal was to have a sprite that moves across the screen, so I set the background tile to something less distracting and hacked in a character, or something like that.
Not sure what it is, but it's something.
I moved the sprite drawing to the core loop and, well, it was flickery. I also realized I wanted some transparency handling and decided color 0 would be my transparent color. Still flickery, but like I said, I wanted something that actually moves across the screen, so I added variables to change the sprite's position in the loop and moved it 1 pixel at a time. There we go. My first attempt to get rid of the flickering was to wait for the vertical retrace. As far as I understand it, it's the brief period when the electron beam reaches the end of the screen and moves back up. During that time, the beam is turned off, so it's safe to make changes to the video memory. It's the only piece of code I didn't write myself. I copy-pasted it off the internet like I guess every programmer does at some point. But unfortunately, it didn't help. I moved the call around in the core loop, but it didn't change a thing. I suspected that everything I was doing in the loop was still way too slow, so I moved the map drawing out of the loop and sure enough, there was a poop train moving quickly across the screen without any flicker. But that wasn't exactly a solution. My next attempt was to use double buffering, so I defined an array the size of the video memory, wrote a procedure that copied the buffer to the video memory, changed the put pixel and draw tile procedures to use the buffer instead of the video memory, and finally added the call to update the video memory from the buffer to the core loop.
There we go.
Slow but flicker-free. I reactivated the statement to alternate tiles every iteration to see what it looked like, and even though it was slow, there was no flickering and the screen was updated all at once. Especially compared to my earlier versions, I thought it was definitely an improvement. But still, way too slow. So my next improvement was to take a snapshot of the background at the sprite's position and size before drawing the sprite. That way I was able to draw the map just once outside the loop, and the only thing I had to do was redraw the background at the sprite's previous location. And, no big surprise, doing less takes less time and it was way faster. I was still waiting for the vertical retrace in the loop, but I wasn't sure if I really needed it. I removed it and it looked like there was no difference at all. However, while editing the footage, I put both versions side by side and not waiting for the vertical retrace is actually slightly faster. Again, it makes sense that doing less takes less time. The question is, should I keep it in? If you know more about this stuff than I do, please let me know in the comments. The first thing I did on Tuesday was to replace the sprite with something that looked like an actual character. I used a sprite to create it, but since I still didn't have an image loader, I hacked in the pixels as hex values. Probably not the greatest piece of art ever created, but definitely an improvement. Next up, keyboard controls. I guess the proper way would be to use an interrupt handler, but the key pressed and read key functions seemed good enough for a first version. And it worked. Kinda. But redrawing the background turned out to be a little glitchy. I could have fixed it in the loop, but I wanted to get rid of some of the global variables anyway, so I decided to move the sprite logic into its own class. Which should have been an easy task, but I got stuck on simple things like how the hell do I call a constructor? Eventually, I found answers to every question, moved code around, and ended up with glitch-free sprite movement. Unfortunately, I was out of time, so I had to call it a day. So far, the background has just been a solid color, even though it was made out of tiles. But the map drawing routine was basically just a loop drawing the same tile over and over again. So I added a structure for the map. Still, no files, no file loading, just a simple hard-coded map. I mean, it's not great, but it looks a little more realistic. The constant speed of the character moving around wasn't so realistic though. I assume hoverboards are pretty much like skateboards, meaning when you push, you speed up and then you slow down. And I wanted that. So I created a subclass for my Marty character because I figured different sprites would have different movement patterns. I added an update method to the sprite class that gets called every frame so specific sprite implementations can do whatever they need to do. I also added a push method to Marty to, well, push. Calling push sets push cycle and speed values. In the update method, the sprite keeps moving while gradually slowing down until the push cycle is over. I played around with different values until I was somewhat happy. I guess it would be nicer with some easing, but it's fine for now. But what's a hoverboard without an ollie? I implemented it pretty much the same way as the push movement. While the cycle is running, I move Marty up, and when it's over, I move him down until he's back at ground level. Ground level being the Y coordinate he started from. Yep, that's another dirty hack, but good enough for now. Then I added some enemies to the mix. Enemies in quotes because they don't do anything bad yet. They just move from one side of the screen to the other, which was easy enough to implement using a new subclass. I moved Marty and the enemies into a sprite array to make it easier to draw, erase, and update any number of sprites. But things were getting glitchy again, so I decided to get rid of the erase method and redraw the affected tiles of the map instead. I guess it's not the most efficient way to do it. If two or more sprites are at the same or overlapping locations, the same tiles get redrawn multiple times. But in this phase of the project, a working solution is good enough. The first thing I realized on Thursday was that I didn't like how Marty lost speed when doing an ollie, so I set his speed to a fixed value while the ollie movement was happening. I'm sure my physics teacher would be disappointed, but once again, it was good enough for now. Having 3 sprites on the screen that looked exactly the same wasn't so great, but I didn't feel like hacking in more sprites or writing an image loader, so I decided to shift the colors. I wanted both enemies to look different, so I added an offset to the constructor. They ended up looking a bit zombie-like, but hey, they're enemies, so I guess it fits. I also wanted to get rid of yesterday's hack in the ollie routine where I assumed the ground position was wherever the ollie started. So I wrote a function that returned the next Y position of the ground tile below a given coordinate. I let Marty drop from the top of the screen and he stopped at the right position. I hacked in a little ledge and Marty landed correctly on it. Most of the time. There were definitely things to improve. I disabled the enemies for a bit to fine-tune the ground position and collision handling. I was a little tired and unfocused that morning, so I'll keep it short here and just show you the result from the end of the session. I started by removing some dead code. Seeing only 21 rows of code at a time definitely makes it hard to keep track of everything. I'm not a fan of the 50-row mode, but maybe I should give it a try. I also brought the enemies back to life. Well, they're actually more like the undead, the way they float around the screen, but whatever. I wanted to add a push animation, so I started by duplicating the hard-coded sprite image and making slight adjustments. I replaced the sprite class's single image with an array of images and alternated them every frame. And, well, it worked, but it looked a little jittery. I added another image to the animation, but it didn't make it much better. So I slowed it down by changing images every other frame. A little better, but still not great. So I changed it to every third frame, and that was definitely smooth enough for me. But of course, the animation should only play when Marty is actually pushing, so I added a flag to toggle the animation state, started the animation on push, and stopped it after one animation cycle.
Magic numbers.
Like everything I've done so far, it doesn't look amazing, but hey, it's a prototype. The two zombie hoverboarders started to annoy me, but I didn't want to throw them out, so I updated the map and moved them out of sight. I also wanted them animated too, and that was really easy because they were based on the same images and the same base class. I just had to make sure the animation flag was constantly on. I thought about adding a water animation to the hole in the lower right corner, but I figured I needed to clean things up first. I introduced a sprite collection to replace the global sprite array and the loops that handled sprite operations within the core loop. It wasn't really necessary, but I guess my object-oriented brain craved this kind of structure. At this point, sprites had fixed dimensions of 16 by 16 pixels. To have an animated 8x8 map tile, I had to make things a little more dynamic. I added width and height to my sprite class and replaced all constants. I added a new sprite subclass named Animated Tile, and its only job was to keep animating. I hacked in 3 images, added a bunch of instances to the sprite collection, and boom. Splash, there's water. It's a little glitchy though. You may also notice that the enemies look like Marty again, and that's because I started using pointers for the image data. I wanted to change their look at the end of the session, but I was running out of time. I finished off by making a few small tweaks to the map, and that's basically it.